Another video for you in the series of synthetic schemes to make desired compounds from benzene. In this synthesis, we're going to try to convert benzene into 1,3-diacetyl benzene. At first glance, that seems like it would be very easy, because we know this is a meta-director. But the problem is it's a strongly deactivating meta-director. So we can certainly put one acetyl group on there readily by Friedel-Crafts acylation, but Friedel-Crafts acylation doesn't work on deactivated rings, which means once we put the one acetyl group on there, we're not going to be able to put the second acetyl group on there by Friedel-Crafts acylation. We're going to have to come up with some other method of introducing this that isn't the Friedel-Crafts acylation. So it looks simple. We've got two meta-directing groups and they're meta to each other, so that seems great. That's easier than the two bromines, which were ortho-para-directors. But we have the complication that Friedel-Crafts acylation stops at 1, which is great, normally. Normally we want to stop at 1 and avoid overalkylation, but in this case, we need the second group on here. So how else can we put a carbon onto the ring? Generally, the way we make a carbon-carbon bond from the ring is by Grignard addition. So we might work backwards and say, if we had this alcohol, we know that we can readily oxidize that benzylic alcohol up here using active manganese dioxide. Manganese 4 oxide will oxidize benzylic alcohols or allylic alcohols without oxidizing other alcohols. And we know that we could have made that from a Grignard reaction onto the corresponding aldehyde if we could convert that into the Grignard reagent. But the problem is we can't convert that to a Grignard reagent in the presence of that ketone. So this is also going to involve some protecting group chemistry. So now that we have a general synthetic scheme, we're going to try to put a bromo group here. We're going to try to make that carbon-carbon bond by Grignard addition and then oxidize the alcohol back up. We can start from benzene and work forward, applying appropriate protecting group chemistry along the way. So we will start with benzene, and we will do a Friedel-Crafts acylation using acetyl chloride and aluminum chloride to generate acetyl benzene, and it will stop because the deactivated ring will not do a second Friedel-Crafts acylation. We can put a bromo group there quite readily because this is a meta-director, and bromination with bromine and ferric bromide, FeBr3, goes on deactivated rings. Meta-director will put the bromine in the desired position. So we have our bromine and our acetyl group. But now we can't make that into a Grignard reagent in the presence of the carbonyl elsewhere in the molecule. So what we're going to have to do is protect that carbonyl with something that is stable to base. And in this case, what we're going to use is the ethylene glycol, acetal. So we'll use some catalytic acid, nitric sulfuric, HCl, in the presence of ethylene glycol, and protect that ketone as the cyclic acetal. That's readily removed in the presence of aqueous acid, but stable to basic conditions because the acetal can only be formed in acid. You can't form the acetal and base, you can only go as far as the hemiacetal. Now we can do a Grignard reaction by treating this with magnesium ether to make the magnesium bromide compound. Grignard reagent will look like this. Without touching the protecting group. And then in step 2, we can add acetaldehyde, and the Grignard reagent can attack acetaldehyde to generate a secondary alcohol that we proposed to oxidize up using active manganese dioxide. We're almost there. We simply need to oxidize this up, for which we'll use activated manganese 4 oxide. We could use chromic acid in this way, so PCC, because secondary alcohols will be oxidized by any of those reagents, and it's not likely to mess around with that. But activated manganese dioxide is a very mild way of accomplishing this. That will generate the second acetyl group that we wanted. And now all that's left to do is to react this with aqueous HCl to deprotect, removing the acetyl group, removing the ethylene glycol group, and generating the product we wanted. So step 1 was to acetylate the ring. Step 2, brominate selectively in the meta position. Step 3, introduce our protecting group to make sure that the ketone won't react with the Grignard reagent. Step 4, form the Grignard reagent and then react that Grignard reagent with acetaldehyde. You could consider that to be steps 4 and 5 if you want to, but normally it would be written out like this. Step 5 would then be to oxidize the secondary alcohol in the benzoic position up with manganese dioxide. And step 6, finally, would be to remove the protecting group that allowed us to run the Grignard reagent. And we end up with the meta diacetyl benzene.